Hi everyone, welcome to week 2 of geometry. We're going to be going over three-dimensional drawing, which is sections 1.02 and 1.03. Again, today we are using Ustream. Please give us your feedback on it. We are looking to make changes starting next week because we know it's not working so great with the ads and stuff like that. So just hang in there with us. If you're watching this through the recording, then at least you don't have the advertisements popping up. So if you have any questions that I don't see during the session, make sure you guys email me at the end and I would be happy to email you back and go over those items with you. So let's jump right in. If you pre-printed the notes, the only thing missing from the notes is the essential question. So whether you're in person or you're at home, you still have to answer the essential question. So here is your essential question for today. It is, if your parent was drawing the 6 orthographic views, what steps would they need to remember? So I'm going to pause for a minute, give you a second to write that down. So through K-mail this morning, I sent you guys some isometric dot paper, and I also recommended that you have some Legos or some blocks handy to build some items with me as we get a little bit later on into the session. So anytime you come in person, I will provide those items for you. I love to see your smiling faces in person, so I hope that you can try and make it Fridays at 11. But if not, if you're at home, make sure you have that isometric dot paper printed out and grab some blocks or some Legos. All right, fabulous. So here we go. Some key terms. By the end of today, I want to make sure, this is kind of like your essential question too. It will really show me if you're understanding today's concept or not. You need to understand what the difference is between depth, orthographic views, isometric drawings, perspective drawings, and then surface area and volume we will do at the very end. So this would be a good check for yourself at the end of today's session. If you can give me the definitions of each of those, then you know you have a really firm understanding of what I wanted you to learn today. So let's talk about depth first. Why do we do 3D drawings? Because it gives us depth. It gives us a new perspective. So 2D drawings are very flat. We can do that on any type of paper. And then 3D drawings have depth. So on your notes, let's sort of highlight this area right here. And let's write that that is your depth of your shape. That's what gives it dimension. That's what gives it that 3D feel to it. So 2D again is flat, 2 dimensions. 3D has that extra depth at the back, and that's what gives it its dimension, its shape. So there's a couple ways we can draw 3D drawings, and we're going to practice all 3 of these together today. First, we're going to do perspective drawings, which is a 3D figure on a 2D plane with a vanishing point. I'm going to teach you how to draw those today. Then we're going to move on to our isometric dot paper and do some 3D drawings. And then lastly, we're going to do some orthographic views. And orthographic views, we draw them in 2D, but we're going to be looking at the top of the shape, the left of the shape, the right of the shape, the bottom, the back. There's 6 different ways we can look at orthographic views. So let's jump right in. Let's try a perspective drawing first. So a perspective drawing is basically a cube, and from the cube, they take each vertice and they draw it to a spot on the horizon. So when we talk about the horizon, think that it's like a horizontal line, horizon, horizontal, see how they're like almost the same. Horizontal line. And what you do is you take each of your vertices and you draw lines connecting from your vertice to the horizon. Vertice to the horizon. That point right there in your notes, can you go ahead and label that's your vanishing point? Vanishing point. So that's sort of the spot where if we were to take that cube and hold it up in front of our eyeballs, that vanishing point would be the spot that we could no longer see anymore. So vanishing is like where it disappears, where your perspective disappears. We're going to try drawing one from scratch now. So if you have your isometric dot paper printed out, we're going to use that. And we are going to draw one of these start to finish. Okay, so the first thing that we need is a horizon. So I'm going to pick blue, and I'm going to draw my horizon. Okay, once you have your horizon, we're going to go ahead and pick a vanishing point. So anywhere on that line you want, can you guys draw a dot? And that dot is going to be your vanishing point. So pick anywhere on your line, put a dot, and we're going to call that our vanishing point. Anybody ever seen this isometric dot paper before? Yes, no, maybe so? It's kind of weird, right? Like the dots, they're sort of offset from each other a little bit. They're like at an angle. Okay, so how we're going to start next is we are going to draw a cube. So let's pick a spot anywhere. Everybody pick one dot kind of in the middle of their page. And I want you to go straight down to the next dot. Does everybody have one edge of their box drawn so far? So we're picking a spot somewhere on our page and you're drawing straight down to the next dot. Now let's go over, you can go over 1 or 2, it's your choice. I'm going to go over 2. I'm going to do another horizontal line. And I'm going to draw in my box. So right now I put a 2D box and we're going to turn it into a 3-dimensional box. Does everybody have their box so far? Okay, so what we do now is at an angle, we're going to find the next dot. So here's what I mean. Let me grab my pointer. So if here's my vertex, here's one of my vertices, I'm going to go at an angle to find that next dot. So from one of your vertices, find the angle to your next dot and connect those two. Now let's go over to my next vertex and at an angle, go up and find that next dot. So what we've done is we're sort of drawing in the top of my box. So go ahead and connect those two. And I am not an artist by any means. These look ridiculously awful. Okay, so same thing. Let's come down to my bottom vertex and at an angle go up to your next dot. And then you can connect those back too. And you have your 3D box. So the way that we make our vanishing point work is we're going to connect our vanishing point to all of my back vertices. So not my front vertices that are in purple, but I'm going to connect them to my back vertices which are in red. So I'm going to do dot, 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 dot. We use dashed lines for our vanishing point. And that's how you create a vanishing point. Okay, so not terrible. Let's review our steps. Step 1, your horizon line. Step 2, pick a vanishing point. I could have picked one on the other side too, right? That would have been fine. Just my lines would have been going the other direction. We drew our front box, and then from there at an angle, we drew the 3D version of the box, the depth of the box. All right, great. Are we ready to try a real isometric drawing now? So this one was called a what? What kind of drawing was this one? Perspective drawing. So let's label it. Let's put that on here. So this one is a perspective drawing. You guys go ahead and label it. Just erased my slide. Pretty awesome when that happens. So that was a perspective drawing. Next, we're going to do a 3D isometric drawing. So this one we can label. Let's call this one, oops, I didn't want to do that. I just need my writing tool. Where'd you go? Give me 1 second. There we go. Okay, so this is our 3D isometric drawing. Isometric drawings are different than perspective drawings because if you guys think back to the last one we drew, we were able to see the front of the box. Did everybody agree with that? We were able to see the very front. And isometric drawing, we get to see from the corner. So this is going to be a corner perspective. So step number 1 is to pick 2 dots. Pick 2 dots and draw your line straight down. That's step number 1. So this is our 3D isometric drawing. Okay, now from here, we're going to make our two bottom parts of our box. We're going to go from the bottom vertex, and we're going to go out at an angle. This is actually going to be a 60-degree angle. Isometric paper is drawn in a way, so that way when we do our angled lines, it ends up being 60 degrees. So it's not the closest dot to itself, it's sort of like in between those two. Can you do your other bottom of your box as well? Okay, so now we have this funky thing, kind of looks like a V with like that middle section in it. Okay, let's do the sides of our box. So the sides of our box, we're going to go from the blue straight up, and from the blue straight up, we're making the sides of our box.
You want me to wait?
Did you just drop that on my box for me?
The forms?
Yeah.
I'll check on the
Yeah, just leave them in my box.
And I need it's a,
The D thing?
yeah, first semester too.
It's I gave them to you in the
No, but I need to like take a sheet of notes and then turn them in.
Yeah.
That's it?
Yeah.
Alright, thank you.
Okay, so the top of our box now, we are going to go from our red line to our purple line, and from our red line to our purple line. Can we sort of see our box coming together? It's just a bunch of vertical lines and sort of angled lines. And see if you guys can finish off your box. Finish off the top of your box. I remember when I was in grade school and they used to teach us 3D drawing, but they didn't give us this dot paper. It's a lot harder when they don't give you the dot paper because the dots are already evenly spaced, so it kind of makes our shape really, really nice. So here would be a 3D cube that you guys just built. Easy? Not too bad? Hopefully not too bad. Alright, so now we're going to get into orthographic views. And if you have Legos at home or those blocks at home that I asked you to grab, you can grab those out now. If you're here in the lab, go ahead and dump yours out of your bag. Alright, fabulous. So first I'm going to show you the one on the screen. Then we're going to practice two together, and then you're going to build your own. So that's kind of the fun part that's happening today. So what an orthographic perspective is it takes a 3D shape. So here I have one on the screen. It takes a 3D shape, and it's going to give you 6 different views of that shape. It's going to give you the front view, the back view, the top view, the bottom view, the left, and the right view. So let's all think about this shape right here. In your online geometry lesson, it actually let you press play and it twisted and turned this shape for you so that way you could see. But let's kind of label this shape. This one's not in your notes. This is one I added at the last minute. So this side right here would be the front. So let's all look at the front. If we were to take that shape and twist and turn it so that I'm looking at it straight on, all I would see would be this. Let's see if that makes sense. So if I were to twist and turn this shape so that way it's totally in front of me, all I would see is this very front edge. Do you guys see how they took that front edge and they just drew it as a 2D shape? We okay with that idea? It gets a little tricky when we start talking about the other sides of the shape because sometimes it's a little bit harder to see. But let's think about the bottom. If I were to look at the very, very bottom, the bottom right now kind of goes like that. Right, the bottom that's sort of hiding down there. So the bottom view is just a solid rectangle. So if you were to lift it up and look straight up at it, all you would see is a rectangle. Everybody okay with that idea? Now's when it gets a little trickier. So let's think about the top view. Here I have this shape, and here's what they drew for the top view. You guys see how they have those extra lines in there? Hint, this might be part of your essential question. See how they have these extra lines in there? What do we think those lines mean? Think about it for a minute. Anybody think they know? Sabella?
The different heights of
the shape. Good job. So if I were to take this shape and twist it so that I'm looking straight down on top of it, there's really 3 layers going on. You guys agree? There's this piece that's this height. There's the middle piece that's dipped down below, and then there's the last piece that's up above. So why is it important for us to draw those lines in? Because in a two-dimensional picture, it's telling us there's a change in height right there. You can't see it on a 2D picture, but you're indicating that there's a change in height there. So left view, if I come over here and I'm looking at it from the left would have a rectangle that's that high, plus this little piece that's a little bit higher than it. So the one that's for the left side, the left view, is the one that has the one little change in height for it. So let me grab my pen back. Oops. We're still getting used to the iPads. Fun, but different. Okay. So my left view right here just had a change in height right there. The right view, on the other hand, already has the tallest rectangle, so if I'm only looking at the right view, I'm only going to see that solid rectangle. So that's the difference between the left view and the right view. One is a solid rectangle, the other side would have the slight change in height. And then we would lastly have our back view, which is where if you take this shape and you flip the shape around, what does it look like from the back? So, do you guys notice anything about the front view and the back view? They are what?
Reversed.
They're reversed. They're just a rotation of each other. Okay, so you guys try. In your notes, I want you to try and draw what does the front, back, top, bottom, left, and right look like for this shape. So try and draw that in your notes for me. There's 6 orthographic views. I want to know, what do those look like to you? Try them out. And I do give you a little hint that this is a square-based pyramid. So I'm telling you what the bottom looks like. Okay, so we should have had a lot of triangles on our paper, am I right? So from the front, it looks like a triangle. Same for the back, same for the left, same for the right. So those 3, or 4 I should say, are going to be the same. What did somebody put for the bottom? The bottom's going to be a square. Good job. And lastly, the top is the tricky one.
Just like a square with 4 triangles in it.
Okay, so it's still going to be a square. You guys are absolutely right, because if I'm looking straight down on it, it looks like a square. But what do you think I could put in the very, very middle? Any ideas? Okay, so there's a change in height, is what I hear us saying. There's changes in height. And where are there changes in height? Here, 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 right? And in the middle, we could even do like a little dot to indicate that that is the highest point. Good job. Excellent job. Okay, we're going to try one more and then we're going to build our own. Okay, so next one. So let's do some more orthographic fun. So you guys try your front, your back, top, bottom, left, right, and then we'll build our own shape. So we're working on this shape. We're making the front, back, top, bottom, left, and right orthographic views. geometry class or the quiz or the lesson, if you ever get a weird shape and you're like, I have no idea what that looks like from the bottom, try and build it out of something you have at your house. Like try and build it with blocks or with cubes or Lego, because then you're going to get a really good idea. You can actually touch it and feel it and pick it up and turn it, and it just makes it a little bit easier to see. So the front should be just what you see on the screen, right? The front should be that exact, sort of like an S. That would be the front view. The back would just be the opposite, would be the flipped version. So once you have one, you can draw the other. And again, my drawings are not perfect by any means, but something like that would be sufficient. So if I'm looking at it from the top, what shape is it going to be from the top? It'll be a rectangle, but what do I need to add to my rectangle for my top? The change in height, so I need to add my vertical line. It's a little more to the right than the left, but almost in the middle, right? Almost in the middle, but a little bit more to the right. That was not nice. And then the bottom, same thing. The bottom would be a rectangle, and the change in height would be way over here, right? Because I would just see that little section. So the bottom would have also a change in height line, but it would be further to the right. The left side would be a vertical rectangle. Did you guys draw your bottom and your left side a little bit differently, hopefully? So the left side will be a vertical rectangle with a change in height towards the bottom. And the right side will be a vertical rectangle with your change in height towards the top, because this is where it changes height, right here. How do we do? Okay? I think sometimes it's hard to visualize them, but the minute you can build them, you're in much, much better shape. So now here comes the fun part. You ready? So we're going to be creative. I'd like you to use between 7 to 10 blocks, and you guys are going to create your own shape. So let's take about a minute to design our shape. So pick out whatever crazy shape you think you can build using 7 to 10 blocks. And if you're at home, use Legos, use blocks, whatever you might have in front of you. So the blocks that we're using in class, they kind of snap together so that way you can put some on the side sticking out, on the top, wherever you want to put them. It's kind of fun. What if I told you you're designing this shape for your neighbor? You're going to switch structures with your neighbor, and you're going to draw the 6 views for your neighbor's shape. Alright? So hopefully you didn't make it too easy, because you're getting theirs. So go ahead and trade with the person next to you, and fill out the 6 views for their shape. And if your shape's totally flat, I'm going to jump in and add one more sticking out. Just for kicks. There's one right there. Okay. Alright, so go. I'll start the timer. We'll do maybe a minute and a half. See if you can draw all 6 views for your neighbor's shape that you created. If you're at home, you're doing your 6 views for your own shape. So if you made a really intricate shape at home, what you're going to find is that sometimes if you add blocks to the back, you may not be able to see it from the front view, but the minute you do the back view, it will be there. So that's why we have to do all 6 views to get a really good idea of what it looks like. if you happen to finish early, we're going to be moving into surface area and volume next, just so you know what we're going to finish the day with. But hopefully you made a really crazy creation at home. It's taken you a minute to do these. So even though we're using cubes, which are perfect squares, just make sure you only draw in those lines if there's a change in height. That's the only time you want the lines in there. Because I know sometimes it's easy to think, oh, I'm just going to draw all these squares. But if you do squares everywhere, that shows me they've all had a change in height, which is probably not what's happening. So I'm a hands-on learner, which is why I love blocks, manipulatives, anything you can touch, move, feel, because geometry is a very visual subject that has some crazy shapes as we get later in the semester. Okay, so we're going to end today with some surface area and a volume problem, and then I will send you on your way. So we're going to jump into surface area. If you notice, there's still 6 things listed next to surface area. So think about maybe why they did that. Because if we are talking area, area is the space that the rectangle takes up. I really have 6 different spaces up there. I'm talking about what's the area of my front, what's the area of my back, how about the left, the right, the top, the bottom. So any kind of a cubed figure has 6 sides. So if I find the area of each side separately, then I can just add them all together and I would get my total surface area. So let's all do the front together first. So my front rectangle would be this one right here, which would be 8 times 6. So the area of my front rectangle would be 8 times 6. I know our brains have been on vacation for a while, but so 8 times 6 is 48, but I'm not just going to write 48. If I'm talking area, what should be my units? Inches squared, perfect. Now, if the front's 48, what would the back be? 48. See, it's not a trick question, right? Because in a cubed figure, it's going to match. Let's try my left side. So my left side would be this purple one over here. And my left side is 8 inches tall by, it's looking for the depth, right? The depth across the bottom. So it would be 8 times 4. So my left side would be 32 inches squared. Great. If my left is 32 inches, what's my right? 32 inches squared. Let's move on to my top. So my top is way up here. Let's work on area. I know that this side is 6, which means that this side is 6. So I'm looking at 6 times 4. So this one would be 24 inches squared and 24 inches squared. So by the time I add them all together, I would get 208 inches squared. So for surface area, if you want to add a note to yourself that says add all areas, that would be great. So anytime I give you a 3D figure, how are you going to find area? Well, you can find the area of each individual side. In this case, there are 6 sides, and I would add them all together. The geometry lesson is going to teach you another shortcut method, but I want you to know that regardless of the shape, if I say find area, you can find all the individual areas and add them together. Because what if it wasn't this nice of a shape? What if it was like a crazy shape like the last one we did, right? Like something crazy like that. Then you wouldn't have a formula. You'd actually have to add all the different areas together. So I'm just teaching you one method. The online lesson will teach you another shortcut method for solid shapes. let's move into volume now. This is our last problem for the day. So volume is just length times width times height. So pretty easy. My length times my width times my height. So let's add in our numbers. So I would get 6 times my 4 times my 8. That one's a little bit easier. So volume would be 192. But what kind of units do I use for volume? Squared or cubed? What do we think? Cubed. Let's talk about why. This is really interesting since we're doing 2D and 3D today. We use inches cubed because look at what kind of a shape it is. A 3D shape. You see the connection? It's cubed because it's a 3D shape. What kind of shape is area? Like just in general. If I say what's the area of that? That's a 2D shape. That's why we say inches squared. Oh, interesting. Okay, so that's where that comes from. Because area is talking about a flat surface, volume is talking about a 3D surface. Does that make sense? Kind of interesting. So that finishes up our lesson for today. Reminder of your essential question. If your parent was drawing the 6 orthographic views, what steps would they need to remember? So what special things do you have to add to your pictures? Something special we had to add to our pictures. So that's your essential question for the day. So no matter if you guys attend in person or you're watching the video, you will still need to answer the essential question in the Dropbox, and that's how you earn credit for today's session. So again, if you're watching online and you have questions, make sure you email me, and I would love to see you in person. Everybody have a great day and a great rest of your weekend.